After the success of the Drayton Welding Open Day, trialling a Migatronic pulse welder for the first time, today we've come down to Migatronic at Doncaster to give another go and see what other features they can show us.
In a fillet weld, which is 2mm, and then basically it sets the amperage for you. Little bit of experience. If it said, for instance, 70 amps, you think to yourself, I can get that at 60. So you know, because you'll get to know your machine. In pulse welding, sometimes whoever's designed the program and the synergic line probably errs on the side of caution. So you think, always a bit 10, 15 amps higher, so you can just reduce it. So. I just moved a bit faster than you.
Right, okay. Just getting used to the speed. Same action, up, down, up, down, up, down, same thickness, but because there's a downhand and you'll get faster, well, going up will concentrate the heat. That's why you don't want to knock it back down. If you try to do that at that level, you'll probably lie in the corner like a dead worm. So whatever I do here now, it says that's what I recommend. Yeah. But depending on the distance between the end of the wire and the weld board, if I add voltage on, that's more heat, so it's going to burn a longer arc length. If I go the opposite way, it will burn a shorter arc. So the idea is, start in the middle, see what you think, and then think, I need to add a bit or take a bit away. And it's the same with the choke, although generally I just run a little bit there. Yeah. I could do it on 0, you know. But I've only got that like on 3.5mm because, as I say, I just happen to know that they'll always run a little bit hotter. Yeah.
you want to leave this down and then
Is this now pumped? Alright.
On 10 now, so I'm going to reduce it to 8. Okay, so what will happen now is I've got Bluetooth lights on this side
Because it's already hot.
because it's already hot.
Yeah.
So if you wanted to tack another one up to this coverall, now in this particular case as well, when you come to tack up, it could go straight into bzz, 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 bzz,
Yeah.
bzz. So what we've got on here is a function called tack mode. So as you can see there, this is the bzz, 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 bzz. So if I activate that, it's taken that out, taken these settings out, and I can now, let's say for instance, we'll put 170 amps on. You can now just do a quick bzz, bzz on there without it going into that mode.
Right.
Okay. And then, so that tacks you your job up, and then you press that one now, and it brings the other functions back in to play. And as I say, let's just take half a volt off. So now when you go down there, you just go straight, and it will do it for you. Turned it faster, it means you can move from A to B a bit faster. So the thinner the material, you want to get from one end to the other a bit quicker. So you can have it going faster, so as you travel faster, it keeps up with you, in a sense, so that the ripple spaces are equidistant all the time. Now, that's equal either or. It's taking the amperage that you've selected, taking 25%, putting it up, down. There is another function here now called sequence repeat. Okay, so now as you can see, it's selected 2 sequences for me. So what I can do now is, I'm just going to put that to 140 for instance. Number 1 will be on 140 amps. Number 2 we can have on 100 amps, or let's put it to 90 amps. No, we'll have to leave it. No, we'll go to 90. So now it's doing what you've just done there, but that's moving it. I'm selecting what I want here. So now what we do is go back into there, go back to here. Here's number 1. Sorry. What sort of time do you want number 1 at? So 0.2 for instance. And then number 2, what sort of time do you want for the second one?
So it's like doing what you've just done, but you've preset it, and one's going to be a shorter time than the other. Okay, now this is ideal when you want to go vertically up.
Yeah, to control your heat down.
Yes. So try, whether you try it on. Just so you can hear it.
Right, yeah. Control it.
We'll have on the pulse at 60 amps. So we've got number 1 on 145. Number 2, you can see it's changing now to pulse, is on 60. Okay, so we'll go back to number 1, and then we'll go back to the times. So we'll have number 1 on 0.2 and number 2 on 0.8. We'll start on number 1. So in this case now, just you'll move it upwards. You don't go back this time. I'll get to the rhythm that it's doing. Based on the type of work that you do. If everything's down at Sigma 1 type screws will be sufficient. If you're going to get structures whereby, I'll have vertical welding and things like that, then the sequence repeat function becomes a benefit, but it's only available in this. So each, you could say, function solution. Sigma Core has got none. Sigma 1 has got so many. Sigma Select has got as many functionalities as we can address. Okay? We've just, this bit is you and I. Yeah. This bit is the torque that we were both. So all we're going to do is move this into different positions and tell it that's where I want you to be, that's where I want you to be. And then we'll do the settings as well as. Okay? So, just going to come back to here. Let's just into some sequences, but nice. So
So basically now we can have different amperages and things like that. Let's bring that back to there. So, oh, he started it. What I was just going to say was, there's no structure in here. So, you need a home position. Somewhere where, when it's done the weld, it returns to go, for instance, and then start. So, the home position. So, we click onto home position as he's done it, set the air point. That'll be alright for there. And we'll just click OK. Each job, whether it's like that, like this, whatever, is called a weld item. So like a job over there is a weld item. Depending on how many welds you've got, they're called weld seams. Okay, so we click onto weld item now, there. And now we should get a green light up here. So now we don't have to worry about this bit. I can run from here. So we have a free drive button there, confirmation of where you want it to be, straight lines or circles, and done. So we'll do this, we'll pull it clear of the job, and then tell it that's where I want you to be, and it equals static. Okay, it has created a point on there, on there. Then we can come into a start position. There, create a point. It's created another point on that. So then we'll go to the end bit. There. That's a linear move, so we'll go for a straight line. And then we'll bring it clear again. And now, what it's done there is, each time I said, we'll tell it it's created me now a structure there. So we can go back to the home position, move to the point. That's the point where I asked it to be. Just move that. And then it's okay. Make sure that's in that position. We can just do a dry run, play it from the beginning. And this should do now what I asked it to do. You can adjust the speed that it moves at. So it's running at 6 milli per second, which is about average for what we as human beings move at. So all we need now is to put some weld parameters in. Click onto weld parameters there, and here's the structure. Well, we're using 1 mil mild steel, which we know is a program 112. Okay. Now at this minute it's in number 1, but we go on to sequence. Let's just go to say sequence 2 for a moment. Okay. We'll go in pulse welding, and we'll go with this duo. Bzz, 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 bzz. Current 160. Voltage trim. We'll have to leave the voltage trim because you don't know until you actually do a weld whether you need to increase or decrease it. Now, as you can see, it's in number 1, but I've put it into number 2 there. So if I press on there and press there again now, when I do this, now you can see it's created the weld parameter in number 2. Stop it there. When it comes back, we can put it into weld mode. So what we can do now is we'll just press play there, play from the beginning, turn that on to weld. Did check it had gas coming through before, so. Job done.
about going round and
When you do anything round now, so basically we can that one's done, so basically that's scrap. So we want a new program. Do I want to save the changes or discard them? Well, I'm going to discard them. So basically, as you can see now, I've got nothing in. So now I need a Miga weld there. So now I've got a structure, home position, set the air point. So that would be the start position. Okay, then you go on to weld item. Okay, so now we're into this. So because obviously you've got this as a fixture and this is a fixture, you have to think, where am I going to start? So basically what I would, looking at you for the life out of me now. So what I would do now is I'll turn this around just so it gets to a point, say there, and now, so that's a point I want it to turn into. So I need to confirm that point, okay, and it's giving me an air point, okay. So then we can say, for instance, come down to there. Confirm that as a point. And now I'll be into the circle move. So we've got the start point in reality, which is there. So now I'm going to split it now at 45 degrees. Circle move. Now it flashes faster because it's telling you now it wants the end move. So now wants the end point, which is there. And now that will have put circle 1. So that's the first quadrant, okay? So I'm always just going to run it past there for the overlap. And that's created everything there. When I come away now to say there and press the confirm, it will have created an arc off. So that's done the outer. To create the inner now, I'll press and hold the airplane and it will give me a second weld seam, and then I could do the inside one, but I have to do that one in reverse, and that's all you would do with that. Okay, do you want to do the inside as well?
yeah.
Okay, so it's created another weld seam there, as you can see. So now right there.
So every circle you've got to do 4 quadrants,
Yeah,
no matter the radius.
yeah, because it gives you a better consistency of movement. It has been done in 3,
Yeah.
okay, but
They're not 20mm tube.
yeah, well, I can show you a video. I think.
If you was to mess up a quadrant, would you have to go back to the start and start it again?
Not necessarily, no. You can go, if you when you do a dry run,
Yeah.
if you find out, don't like that, go to the beginning of that section,
Yeah.
and
Change which
and then
one
it
you
tells
use.
you on here whether you're accepting it or whether you want to reset the point. Right, that's everything sorted. So basically, I'll hit the home position and move to the air point. That's okay, that's okay. Turn that back to there. That's all right there. Eyes.
So if you were to do a second run in there, can you just repeat that?
We have what they call a multi-run program.
So
I've never used it. John's the only one that's ever played with it. And well, that inside there DC, or I didn't want to do it in duo, all you would do is you'd copy and paste the weld parameters and insert them between the last air point there and the next weld seam, and then you change those settings to what you want it to do at that particular point. We've got what we call a statement piece, and it was 2 round tubes with a piece of plate between them. So you do one, let's say it's like that, with a piece of plate between here. So you'd come vertically up on one, and that has to be a separate program to begin with in sequence repeat. So you do that one first, then you'd go vertically down, and then it would come round here, and then it would weld round there in, say, DC. Then it would, as soon as it got to that corner, it would change into DC pulse, bzz, 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 and then you'd go into pulse, and then into pulse, bzz, bzz, bzz. So you would show people all the functionalities that the machine could do within one weld, you know. And then if you were sort of, say, in a sense, when you come to a corner like that, obviously you're welding at that angle, and then you need to change it. So when you get to there, you basically add a linear and a linear and a linear. So you just put those in, and it just tweaks it around for you, around the corner, and then carries on once you've got the right sort of angle.
Very clever.
We have the various shrouds for this. This is obviously the full size one. We have bottle ones, and then there's one that comes down to 10 mil for real tight access. Again, if you're doing stainless steel or aluminium, not a problem. The only thing about what I didn't say on there is that, oh, I must have one in my pocket. There, just. If I was doing stainless steel, I'd use that contact tip, which is a longer one than standard. Okay?
In the robot?
In either the robot or the handheld torch,
yeah.
Because it brings that full to the end of the shroud.
Okay.
You don't want too much wire sticking out because it overheats and then it oxidizes. Instead of using the wire, because some people when they program it can touch the job with the wire, it pushes the wire back and you think, oh, I need to move the torch further in, so your torch is going in and out. But if I take the contact tip out and put that in, that's a movable piece. So now I can touch it exactly where it wants to go, touch it where it wants to go, touch it where it wants to go. And then I know then that when I press the go button, that wire's always going to be in exactly the same position. So.
So as you can see, we're not leaving empty-handed. As always, Migatronic always comes up with goods. A really good demo today, and yeah, taking it home. See what stainless and aluminium we can come up with now, guys. See you later.